Yeah. Okay, guys. I want to test my microphone. Hello. Hey, guys. I want to test my microphone. Hello. Hey, guys. I want to test my microphone. Hello. Hey, guys. Well, here we want to talk about convergence. It says time convergence time describe how fast network describe can reach the state to convergence after a topology change. Business continually requires high availability of the network service. To minimize downtime and quickly respond to the network changes, a fast convergence time is desirable. Speed of convergence can be influenced by several factors. One of the determined factors is the choice of routing protocol. Each protocol uses a different mechanism to exchange information, trigger updates, and calculate the best path. While IGPs uh, achieve acceptable convergence time using default setting BGP as an EGP by default, react to the network changes in the slower manner. There are several ways that you can influence convergence time. The first common option, let's highlight it, is to fine tune timer that are used by routing protocol. Tune timers enables you to instruct the routing protocol to exchange information more frequently. With faster timers, network change is detected more quickly and information about change can be sent sooner. Keep in mind, however, the that faster timer also introduce greater protocol overhead or higher utilization on less powerful platforms. The second common option to influence convergence time is to configure route summarization. Route summarization, let's highlight this, it's important. Reduce the amount of information that need to be exchanged between the routers and lower the number of the routing that need to receive topology change information. Both of these conditions help lower the needed convergence time regardless of the protocol that is used. And what is route summarization? Route summarization enable you to reduce routing overhead and improve stability and scalability, sca- stability and scalability of routing by reduce the amount of routing information that is maintained and exchanged between routers. This result is in a smaller routing table and improved convergence. The purpose of route summarization is to squeeze several subnets into one aggregate entry that describe all of them. As shown as in figure 1.5, route summarization reduce the size of routing table because only one summary route is received by router B instead of 8 more detailed routes. Let's find out what does that mean. For example, we have these networks 0, 1, 2, 3, 4, 2, 7. Okay, here we have a I think more than 9 routing protocol, so we can summarize it to this. So we write 10 12 0 0, for example, in which means we every networks in this range let's in this range 10 12 255 255 slash 21 is accessible. Okay, route in addition route summarization also reduces the number of updates that need to be exchanged between these two routers. For example, examine the event of network change when network 10.12.6.0.24 becomes unreachable. Router A does not need to inform the neighbor about unreachable prefix because the summary route is not affected by the network change. Less frequent and smaller updates as a result of routing summarization. So less frequent and smaller updates is the advantages of the route summarization. Also, route convergence time for also lower convergence time. So we have a 3 advantages. For this reason, route summarization is heavily used in larger a network where convergence time can be a limiting factor for further network growth. Different routing protocols support different router summarization options. While distance vector protocol support route summarization configuration on each outbound interface. Link state protocol support summarization only the area boundaries. So let's review what is link state and distance vector and path vector. So OSPF version 2.3, ISIS for version 4 and IP version 6 only accept inbound. But distance vector like RIP version 3 and RIPNG, ERGRP and ERGRP for IP version 6 accept outbound. You should be consider this. When planning for route summarization, also keep in mind that in order to implement route summarization efficiently, IP address must be hierarchically assigned in configuration blocks across the network. Routing protocol scalability. As a network grows and become larger, the risk of routing protocol instability or long convergence time becomes greater. Scalability describes the ability of a routing protocol to support further network growth. Scalability factors include number of router, number of adjacent neighbor, number of routers in the network design, frequently of change, available resource, for example CPU and memory. The ability to scale the network depends on the overall network structure and addressing scheme. The number of how to pronounce this? I don't know, really. Honestly, I don't know. Where is the pronunciation? Where are you?
From the library.
Oh my god, what happened? Okay. Where we are? The number of adjacent neighbor, number of router and number of routers along with their utilization and frequency of network changes are the impacting factor that affect protocol scalability the most. Hierarchical addressing structure address assignment and route summarization improve the overall scalability regardless of routing protocol type. Each routing protocol also implements additional protocol specific feature to improve the overall scalability. OSPF, for example, support the use of hierarchical area that divided one large network into several subdomains. So I should highlight this. OSPF support use hierarchical area, divide one large into several subdomains. EIGRP, EIGRP on the other hand support the configuration of stop route to optimize information exchange process and improve scalability. Such a nice routing protocol. The scalability of the routing protocol and its configuration option to support a large network can be play an important role when evaluation routing protocol against each other. Okay, let's go to understand network topology. You can establish routing protocol over a variety of different network technologies. It is important to consider the limitation of a specific solution and how it affects routing protocol deployment and operation. Upon complete this section, you will be able to difference traffic types, difference IP version, 6 address types, describe ICMP version 6 neighbor discovery, difference network type, describe the impact of NBMA non-broadcast multi. Oh, I don't know about it. On routing protocol, describe how the internet break enterprise routing. Traffic types. Traffic types. By using a specific destination IP address type, the device can send traffic to one reception to the select receptionist or to all devices within a subnet at the same time. Routing protocol use different traffic types to control how routing information is exchanged. Selecting distance IP according to different address types enable a device to send different type of traffic. Unicast. Okay, guys, we have a few types of traffic types, so it is important to know about it. I want to describe one by one, and if you have a question here, please ask me. The first one is a unicast. Unicast addresses are used in a one-to-one context. Unicast traffic is exchanged only between one sender and one receiver. Source address can be only be unicast address. Be a unicast address. This is obvious. For example, we have a switch here here S1. We have a PC here. We have another laptop here, and it says when a B. It says unicast address. Our use is the one to one context, here to here. PCB send packet here via switch 1 and receive the response one by one. It is unicast. It is simple and obvious. Let's find out what is what is multicast address. Multicast addresses identify a group of information across different devices. Traffic that is sent to a multicast address is sent to multiply distance at the same time. An interface may belong to any number of multicast group. In IP version 6, the received address space range for multicast addressing like this. For IP version 6, received multicast address have the prefix this. Okay, we need to add a router. Here we have a different SW2. Stable S3. Okay, here we have IP version 6, for example. We have IP version 6 here. If a sender from PCA want to send a packet, multicast packet, the traffic goes like this. It goes here and it goes here. We have a multicast actually. Even if PCA has a IP version 4, it doesn't matter. IP v4. It doesn't matter. We have a IP version 6 here and IP version 4 here. It sends multicast even if the multicast address have a prefix $00/8. Okay, and let's describe anycast. An anycast address is assigned to an interface one more than one node. When a packet is sent to any cast address, it is routed to the nearest interface that has this address. The nearest address is found according to the measure of the distance of the practical routing protocol. All nodes that share the same address should behave the same way to the should behave the same way so that the service is offered similarly regardless of the node that serves the request. A common use case for anycast is the Internet DNS server. There are several interfaces of the same server across the world, and anycast enables you to reach the nearest one by simply using the anycast Let's do. Okay, where we are, uh, here. Enables you to reach the nearest one by simply using the Anycast destination address. The arrows in the figure for Anycast indicate that one destination is closer than to other. Broadcast. IP version 4 broadcast address are used when sending traffic to all devices in the subnet. Information is transmitted from one sender to all connected receivers. Local broadcast address 4 times 255 is used when you wish to communicate with all devices on the local networks. Be careful, it says local networks. The directed broadcast addresses, which is the last IP version 4 address in each subnet, allows device to reach all devices in the remote networks. Direct broadcast address, which is the last IP version for address in each subnet, allows a device to reach all devices in a remote network. IP version 6 does not use a broadcast. It is so important, guys. Please remember, IP version 6 does not use a broadcast address, but uses multicast address instead, as discussed in the next section. IP version 6 address type. Okay, here we have a conceptual of the all types of traffic in the network. Here we have this is the source C. This is the destination, guys. Source and destination. In the unicast, here it is our network. We have for example, router 1, router 2, router 3, and router 4. In the unicast, it directs to destination. In the multicast, maybe we have a 2 paths to sending traffic. In the Anycast, we send to the nearest destination, and in the broadcast we send to all in IP version 4, just IP version 4. So it should be considered. And in the broadcast, we have just IP version 4, as we talked it before. Early routing protocols use only broadcast to exchange routing information. Broadcast message containing routing updates unnecessarily utilize other devices that were connected to the same network, because each device needed to process broadcast packet when they were received. All modern IGPs use multicast address. So here is important, I highlighted. To perform neighbor discovery. Neighbor discovery is important, and we can discuss more about it if you have a question. Exchange routing information and send update. Table 1 to list some of the well-known IP version 4 and IP version 6 multicast address used by routing protocol. Notice that the low order value in the multicast address are same both IP version 6 and IP version 4. So it doesn't matter we have IP version 6 or 4. The low order value in multicast address is the same. Okay. Well-known IP version 4 and assigned IP version 6 multicast address used by routing protocols. IP version 4 multicast address and IP version 6 multicast addresses. In OSPF version 2, we have this multicast and IP on OSPF version 2. All designate routers is this, and so on. Okay, guys, let's. Hello. Okay, there are several different basic types of IPv6 address as shown in the figure 1 to 7. It is important that you are familiar with them since some of them are also used by routing protocol. IPv6, unicast, multicast, anycast, as we discussed already, assign and side node, global unicast, link, local, loopback, unspecified, unique, local, and embedded IP version 4. Global, local, link. Nice. I got it. RFC 3587 specified 2000/3 to build global unicast address space that the INA may allocate to regional internet registration RIPs. A global unicast address is an IP address from the global unicast prefix equivalent to the public IP version address. These addresses are unique and globally routable. The, allocation and struct of global unicast address enable the global running table. Global unicast address uh, where we are that are used on links or aggregate award through organization and eventually to the RIPs. IP version 6 link local address use the prefix link local address use prefix FEAT 10 equality 4 times 11110, and any device that is an IP version device must be at least have a link local address. So it's important to know any device that is an IP version device must be at least have a link local address, which automatically configured by default using EUI 64 or the privacy extension. Although the link local address can be statically configured, uh, although the link local address can be statically configured. Router typically have a statically configured link local address address to make the address more easily recognizable when looking at IP version routing table and examining IP version 6 routing protocol information. Nodes on a local link can use link local addresses to communicate. The nodes do not need globally unique address to communicate. Link local addresses are not routable. Therefore, only stay on the link or network. Multicast network addresses are heavily used in IP version 6 as there are no broadcast address. You can recognize them as part of the prefix FF00/8. There are both assigned and solid side nodes multicast address. Routing protocol make extensive use on the assigned multicast address. Assigned multicast address are similar to well-known multicast address in IP version 4 used by routing protocols such as EIGRP and OSPF. Solid side node multicast address are used by ICMP version 6 neighbor discovery EIGRP and OSPF. Okay, guys, I think this is enough for today, and I'll see you soon. I think tomorrow. See you later. Bye.